off yesterday. So in this question, right, we're finding the volume by taking the area between these two curves. So you got a little square there as an example. That little rectangle, that little square, gets rotated 360 degrees about the line y equals -5. So we'll always have a big radius and a little radius, right? That purple thing, no, that's good. Okay, so we have a big radius and a little radius. And we need to make each of those washers and then add them all up. So what is our big radius? Well, our line on the top is our red line, that's 2x. Now 2x would give you this distance. 2x always gives you the distance from that point down to the x-axis. That's your y coordinate, your y value. And now, since you're revolving it around -5, you're adding 5 to that radius. Does that make sense? So now my bigger radius, it was 2x when it was just going around the x-axis, but now that we're going around y equals -5, we're adding 5 to that radius. So my big radius here is going to be 2x plus 5. And it gets squared because I'm making a circle, pi r squared. Same thing, my small radius was, right, this little part from here to here, that's x squared, but now we need to add 5 to it to make my small radius, so it will be x squared plus 5. And that all gets squared because we're making a circle with the small radius. Taking the one circle and subtracting the other circle makes a washer. And if we add up all of those washers, we would get this cone-shaped volume. Of course, you can combine your like terms. I'm sure you all copied this down already. And the rest is our regular integration. So we'll do one more example like this. This time we'll revolve around a vertical line.
I thought I understood, but now you changed it.
I should go back to it?
No.
No?
Now I have to restart my learning again.
Restart your learning again. Because we're going around different axes?
Yeah.
I mean, one of the things with the washer method, you're always taking your big radius minus your small radius. You take your big circle and you minus your small circle. So if you have that in mind, it's going to be easier to figure things out, even though, like if I show you the equation that you're going to write out, initially you're going to be confused when you see it. How did you get that? But if you think about big radius minus small radius, life will get easier. So first of all, always a little bit harder rotating around vertical lines, rotating around y. It's a little bit harder because you would have to change both of your equations to x equals. So this line, my straight line, instead of y equals 2x, I rewrite it as x equals y over 2. And my parabola, instead of y equals x squared, I rewrite it as square root both sides. And we're only taking the positive part, so that's why the plus or minus isn't there. It's just the square root of y. So when I'm thinking about rotating this little section, and I'm rotating it around here to get this washer that we see in the second picture, we have to think, how big is this outer radius in blue, and how big is this inner radius in green? And what I know with my equation is if I know that I have y over 2, when I plug something in, I figure out this length from my axis to the graph. Whenever you plug that in, when I plug something in for y, the x value that I get is this length. So now, if I know this length right here, and I know this length is 2, does it make sense that the blue line would be 2 minus that length? And so in my equation, that's why it comes up as 2 minus, and the red graph is y over 2. That y over 2 is this little blue length in the first graph. That's my big radius, so it gets squared. Then I need to subtract my small radius. Well, my small radius, same idea. I would know this length is the square root of y. That dotted black line is the square root of y. So if I want to find this inner radius here, and I know this length, I would have to take 2 minus the square root of y, and that would be my small radius. The setup is the hard part, besides the drawing. The drawing is hard too. The setup, the drawing, getting started is what makes these ones hard. Visualizing it is hard. Do these pictures, can you see how if we add up all of those discs, we would get, oh, a party hat? Looks like a nice party hat with extra support in the halfway up, so it wouldn't collapse on you. Now in this question, we would have to square each of these. And the rest is basic integrals. So it's a little bit annoying maybe with the square root and squaring things out and multiplying things out, but combine your like terms and solving is not hard after that.